So we, in the Zeiss Rodriguez group, we work a lot on the interface between the prior knowledge that we have and the data we generate about molecular phenotypes, let's say. And we want to make it a bit easier to go down this road for people that may not have this very specific focus. And so that's where this project originated. And I will go a bit through the more obvious functions of it, and I'm hoping to get a bit of feedback on what you think would be useful to focus on going forward. So I'm pretty sure that most of you are very aware that biomedical data is a very heterogeneous mess in terms of how we collect it, how we share it, and also generally conceptually, because we talk about very different things if we talk about tissues versus phenotypes versus drugs. And to make things worse, everything also follows its own arbitrary format in the most part. And this has led to the creation of a really large number of heterogeneous knowledge graphs for different purposes from different consortia in different domains, let's say, of molecular inferences. And our own knowledge representation that we've been working on for, excuse me, for about 8-9 years now is called OmniPath. It started out as a small-scale, very curated resource of validated interactions between proteins, so this part over here. And in general, it was always driven by the demands that we had in our computational methods of inference for the data that we wanted to use. And so over the years, it has grown to include other different types of annotations on top of the protein-protein interaction network. So we see an increased amount of complexity generally as we continue to expand it. And also, we now at this point observe that even though we primarily develop OmniPath for our lab, even the interests in the lab diverge so significantly that we observe this no one-size-fits-all effect, even among the people that are in direct contact with OmniPath development. So we wanted to generalize the build process of these knowledge bases to allow flexibility of project or task-dependent knowledge graphs. And then we also had simultaneously the issue that we wanted to migrate the DBMS backend because we wanted to include, for example, microbiome information, then you get exploding complexity in terms of the data that you want to represent in your knowledge graph. And for both reasons, we kind of ended up developing this framework, which we now call BioCypher. And it is, over the time, it has become a sort of triple modularity framework. And the three facets of modularity are A, the resources, so the primary sources of our knowledge that can be in different formats and different identifier namespaces or whatever. And for this, we want to maintain a range of adapters that can communicate with the BioCypher core. The second facet of the modularity are the ontologies, which have been used for quite a while to harmonize biomedical inference and knowledge collection efforts onto a common scaffold, so to say. But there are many, and they're also not complicated. So to facilitate bringing these two together, we kind of enable the flexible configuration of the data resources coming together with the ontologies in a project-specific manner. And then the third component of the modularity is the output or the knowledge graph that you work with. And this could either be something like OmniPath, a curated resource that many people use for informing their own individual projects, or it could also be a project-specific knowledge graph that only extracts what you need for a specific analysis and then makes this easier to, for example, archive and share for reproducibility reasons. And this kind of putting things into a framework brings its own complexity with it. So if you allow modularity and then say you want to kind of rationalize the efforts in the community so that not everybody has to maintain their own huge knowledge graph, you somehow have to make this findable and accessible. And so we have for now decided to make the project board for our GitHub repository the ground truth of what is out there in terms of adapters. So I'm currently collecting all the efforts that are known to me here, and then also classify them in terms of primary, secondary, ontology, and output adapters. And for this, we even revived discontinued ontology, which is called the biomedical resource ontology, which was done maybe 10, 11 years ago, but then not further used. But it's actually quite suited for the purpose because it describes softwares and the different research areas that use these softwares. So there are also some other functions that we use this board for example, planning larger scale projects, managing the contributions from the community, and have some high level example pipelines that people can look at and learn by example from if they look for a accessible way to create a knowledge graph for their project. So for example, you could see here that we have a pipeline for the biotech and for Drugstone and for the impact of genomic variation on function projects. And then on these cards, I collect information about which adapters they use on the input side, on the ontology side, on the output side. And then going from that, you can think about what you can reuse, what you would like to add maybe for your own pipeline. So briefly to the adapter side, what is an adapter? In principle, it's the same extract, transform, load process that everybody knows and loves, but in a modular fashion, so to speak. So as a mid to long-term goal, we have this repository of primary knowledge sources that can be freely recombined. And for that, we need the individual adapters to communicate the kinds of information that they carry in an accessible way. Currently, we do that in Python, but we hope to elevate this to also even more accessible functionalities so that you can then select, for example, the organisms that you want from UniProt, and you want information about the length and the proteome of one specific protein in your knowledge graph, and maybe connect it to organisms and to genes. And then this should result in harmonized knowledge graphs that are the same as before, or maybe more flexible than before, but on the basis of this framework. And this is currently on the roadmap to then take the information that these adapters provide to the BioCypher core and make it more automatable in the sense that every one of these adapters could automatically transmit the types of identifier systems that it uses, for example, to the pipeline. And then the user can get an overview of what kinds of identifier namespaces, for example, are available in the project, and then select the one that has the most overlap in the primary resources. A bit about ontologies. So I called this the necessary evil, and some people may disagree, but we cannot assume to communicate with computers or machine learning methods, or them to communicate amongst one another the way that humans, and particularly human domain experts, communicate with one another, because they spent a lot of time as kids growing up building a world model and building language capabilities and communication. And then they spent another couple of years to acquire a specific vocabulary and context for a specific job that they're doing, for example, biomedicine. Whereas large language models, as advanced as they may be, sometimes still struggle with the world model and also struggle with context a lot. And so we have lots of ontologies that many people put a lot of effort in maintaining, that we can use to project the data that we generate onto. And for BioCypher, we realized that this is a very important step of the process in general. And so we want to make this as accessible as possible also. So for example, a very high-level example would be that you have decided on a couple of resources that you want to use, but you need two ontologies, one that is kind of broad and shallow, biomedical domain like BioLink, which just has lots of different types of areas inside the biomedical field covered, but doesn't go too much in depth on any of these. And you maybe build a graph for oncology, so you need lots of granular information about how sequence variants behave or how they can be different. And so we allow the user to just take the subtree of the sequence variant from the sequence ontology and tack it onto the BioLink ontology. And then you can have a hybrid ontology that informs your knowledge graph as a scaffold in the back. And what the decoupling of the ontology and the knowledge representation gives us is that we can then, as advanced measures, enable, for example, reasoning prior to building your knowledge graph. So you could, for example, take a couple of disease ontologies where we have maybe the highest discrepancies between the individual ontologies, and then try to do some reasoning before you build your knowledge graph so that you can harmonize between Mondo and the disease ontology and maybe experimental factor ontology, and then maybe get something that is just more homogeneous as a result. So quickly about the use. At the moment, we are at the level of, let's say, if you don't want to develop an adapter, it's low code, but still Python. So you import the core module as a class instance, and then for each of the adapters that you use, you import them from where they are built. So in this case, we take from the Crossbar project the UniProt adapter. And this, of course, has some settings to tell the UniProt adapter that we only want human and zebrafish, for example, and these fields. And then you write your knowledge graph. This is, of course, a minimal example, but you would proceed like this for each of the resources that you have. And to map this to the ontology, we need a configuration where you take the data that the adapter gives you, where this would be called the protein, and you say, I want to use UniProt IDs for all the proteins, and you map them to the corresponding class in the ontology, which incidentally also is called protein here. And the same for all of the other constituents of the graph that you may want to use. And then there's some functionalities like defining properties on these that I'm not showing here. And then you get BioCypher to build your knowledge graph, and this could be in different formats depending on the output adapter or adapters that you choose. For example, you want to label property graph in Neo4j, then you could use the Neo4j output, and then BioCypher generates you A, the data in Neo4j format, and B, a shell command to also import this into Neo4j. And we also have Docker solutions for this, so this can be run on a server and automatically. And then if you want, you can optimize this either by iterating through it manually or by maybe doing some fancy algorithmic stuff with the configuration that you have to get the knowledge graph that is best suited for your particular project. We can do some stuff in the adapters. For example, in this case, we were looking at UniProt, and they do not provide gene identifiers. However, they do provide transcript IDs for their proteins. So we use our PyPath, which is the backend of OmniPath, so to speak, to map these transcript IDs to the gene IDs. And with this, we enable mapping of genes to proteins, so we can provide with the UniProt adapter this gene to protein edge that wasn't originally in the UniProt data, which then facilitates integration, for example, with the Open Targets platform adapter, which is a gene-centric resource, so they don't have a lot of protein information, at least not consistently. What it also gives you to pack all this into a framework is that you get added robustness compared to the mainly manual methods that we use today. So if you write together a couple of scripts to harmonize some resources, which isn't more complicated than writing a BioCypher adapter, is that most of these probably will not be unit tested, whereas BioCypher is. And so if you have a pipeline that uses such a modular approach to creating your knowledge graph, we can get feedback on what happens during the process. For example, we may have duplicates, you forgot some inputs, or this doesn't seem to be a UniProt ID. What did you actually give me? There are some basic, at the moment, basic functionalities to make life easier for the persons creating the graph, for example, by giving an overview of all the constituents of the knowledge graph as are currently defined in the schema configuration. So you would see that you have in this is from the tutorial. So we only have some proteins from different resources. We have protein isoforms, we have got complexes and PPI. And in more real world oriented graphs, this can get bigger quite easily. And we can also look at the full ontology if we want to. For example, we would like to find out what are the classes that we have available. So this is kind of the basic functions that we have built in at the moment. And the same extensions can also be used to include other community methods of people that may be in the audience right now. For example, we could use bioregistry functionalities to parse and validate the identifiers. And what we didn't do, but what I thought would be maybe a good idea, is to use Gilder for the automatic rounding of the constituents of the knowledge graph, if that is required in the process. Another point is licensing. So it's something that's not very popular in the knowledge graph community, particularly in academia, but something that should get more attention, probably. So with the framework, we can have a more granular representation of license information, in that we can have this information on each single graph entity, as opposed to having a table where you say, I took stuff from drug bank and drug bank has this license, and please get in contact with KEG if you want to use this part of the graph. We can just put it onto the entities themselves directly. And we also have implemented a strict mode, which kind of prevents even building a graph if not every entity that goes into the pipeline has at least a source version and license attached to it. And then this is a planned feature. For convenience, we would like to have some sort of master switch for particular use cases. So imagine you're an academic researcher, then you can say, I want to use this information, this pipeline, but give me everything that's free for academic use. Whereas a company would have to flip the switch and say, I'm only able to use the contents that are licensed for commercial use. We also want to have some downstream clients. While they're not strictly part of the BioCypher framework itself, I think they could still be part of an ecosystem. So we're working in our lab, we're working a lot on inference methods driven by prior knowledge on causality. And one of these is called Cornetto. It's an ecosystem that is basically the evolution of Carnival, if you're familiar. And we would like to do functions that can, in this framework, like in the inference framework, you can have a function that says from BioCypher, and then you just connect to a BioCypher instance that could either be an in-memory graph or something that runs on a database in the backend or on your server. And then you get a knowledge representation that is tuned to the method that you want to run on. And then you can run it. Like this would just create the constraint formulation and the extended graph that Carnival creates for the graph that it took from BioCypher and solve it using one particular integer linear programming solver. So I mentioned that we have a Docker workflow already. We have a template repository, and there we can build and automatically mount an endpoint for the knowledge graph that has been created. And what we would like to see is basically a collection of representative workflows for the different sub areas of inferences and connections of prior knowledge to inference mechanisms in the different fields that we work in, and also other fields, of course. And I've already started on making a metagraph of these components. So this is a state of the repository right now where lots of the individual adapters are still missing. But what I do basically is I have the GitHub API give me back all the issues from BioCypher that are collected in this project management board. And using this biomedical resource ontology, we build a BioCypher graph about BioCypher that tells you about the adapters and the pipelines that use these adapters, which ontologies are used, and also which areas of research are concerned. So if somebody comes naively to the project and says, I am working in proteomics and we work with cancer patients, what are the pipelines that are closest to what I want to do? And then they can see whether they can reuse the existing adapters or whether they maybe need to add their own. I already said that ontology reasoning prior to knowledge graph build to, for example, harmonize disease ontologies would be one outlook that is very attractive to me at the moment. A second one would be to improve the interaction between the adapters and the BioCypher core and the knowledge graph in the end by not passing around collections of the graph entities, but rather use something like Apache Arrow with pointers towards disk or memory objects to not have to pipe a lot of data around, basically. So save time and memory in the application of the pipeline. And then also going for more intuitive interfaces. So this is, I don't know, if you've seen something like this, this is a modular synthesizer, or at least part of one. And I'm an audio engineer from a previous life, and I always liked the interfaces that these types of software, but also the hardware components give you, in that if you work with them a bit, you develop an intuition about, if I turn this knob a bit to the right, what will it sound like? And I think we don't have that for knowledge representation. So at a very abstract level, we would like to improve usability by different groups of users, but the problem is to decide at which level do we act. Do we create a better Python wrapper? Do we create more expressive Python functions? Or should we rather go into the direction of doing TypeScript applications where people can then drag and drop stuff? This is kind of at the conceptualization level at the moment. So I'm also very happy to hear your opinions about this. To stay up to date, you can go to biocypher.org. We have links for all the relevant things, like the chat that we established for users and developers, the template repository. We have a tutorial there that you can easily run in like 20 minutes to see whether it makes sense. And yeah, that's it from me. Thanks a lot to all the people that were involved in the project so far, and to my fellow researchers in the lab here, and to you for your attention.
Thank you very much, Sebastian. I'm going to open the floor for questions, and while folks put their hands up, I might start with one of my own. I was curious about the grounding of entities. So if you take a couple of data sources, do these not get grounded when you sort of try to combine them with ontologies? Is that a separate?
Well, yeah, it's not separate, but at the moment it's a manual, it's a human job, right?
I see.
This comment was more in the direction of how could we make this more streamlined in terms of that you don't even need to worry about grounding every single one of your input streams. And yeah, this isn't a very well-developed thought, but I think I'm mainly coming from the perspective of we're doing this to save time for the researchers to think about the more higher level questions in research, to not worry about the menial things of stuffing data into the right drawers. So that's kind of where this came from.
And this is also the issue
That makes
why
total
a lot of
sense.
things
But
are not
I do
compatible
agree
with
that
each other.
investigating
It's
something like
actually how we
Gilda
give a
or
metabolite
even
a
the work that you've been
nomenclature.
doing here with
I
this
know for
text tool
untargeted,
would
that's a
be
different, like,
perhaps a good way to go at
right? It's like even though we
harmonizing these
propose
free
to
text
even
descriptions
define a
to
metabolite
ontology
name
terms
to
or
be
to whatever
predefined,
ontology is being
which
used.
I wonder how
Yeah.
do we even intend to compare the different peaks that are found in
Charlie,
different
you wanna-
labs, given
your
there can be
hand up?
different columns, there can be different illusions, and so on and
Sorry,
so
I
forth, which
completely
obviously
missed this last
bias
question. Whoever's
the
got the
metabolites being
person talking in the
detected,
background,
and
could
then
you?
like towards the targeted
Yeah, that's me.
metabolites.
I'm sorry. We had some confusion with the times, so we had both have meetings in the same room. I'm looking for the Zoom controls.
Do you think you could quickly recapitulate the last answer that you gave, because I couldn't hear it at all? Okay. Anyway, so we could just
maybe Rafael could do that because my colleague is still talking here.
Like being specific.
Oh, sorry. So from my understanding, this is a separate process right now. They're sort of focusing on the higher level directions rather than this fine-grained sort of configuration of what, data sort of what input strings get mapped to what ontologies and how. And so I think it's left to the user entirely at this point, but it's expected to be automated at some point in the future, either using Gilda, as Sebastian mentioned, and then I added that we've been working on this other tool called text to term, which I talked with Ben Curie about, who is in the audience as well today, and it's something that allows you to sort of automatically take some collection of free text terms and map them to some ontology of choice. And so I consider that could be potentially useful.
I don't know that, but that sounds really useful for that. Text to term, you said, right?
Text to term, yeah.
Yeah, I'll have a look.
Okay, thank you for recapitulating that. My question's a little bit also on the higher level. Given like you've got this list of people who have made all sorts of different knowledge graphs, and like the number of solutions are enormous for building and analyzing knowledge graphs. But I think the interesting thing from hearing you talk about this stuff is actually on the collaboration level. And so I've got kind of a smattering of questions. So like first, how do you get people interested? And like, how do you go about communicating with people who aren't like, hacker type people like us, who like writing Python code and we like making databases, that kind of thing. But like you go to the clinic and maybe in Heidelberg and you say, hey, who's doing, clinical genomic variation analysis? And like, how do you get those people into the room and how do you get them interested? And then like, how do you make meaningful projects other than, just showing them a bunch of stuff they don't really care about? They say, yeah, oh, cool, that sounds great. You want to collaborate with me? Make me a knowledge graph because I heard those are cool. And so that's great. Like collaborations can kind of end with that, where you can say, oh yeah, we made a knowledge graph for these people who work on these things, which is like the sum of 6 other knowledge graphs that everybody else uses. But like, what's the real impact of that? Like, how do you take it to the next level where you build something that's actually useful and that there's some kind of back and forth? So maybe you can like give an outline of one of these kinds of projects if that already exists, or does this question make sense?
No, that's definitely the thing that I think a lot about. And we have some of these collaborators already. Are you able to hear me fine?
So like,
or is it good? Okay. So the thing is that it's a lot of communication basically. So this project is maybe more communication than it is working on the Python hacking stuff. And so far I've made good experiences, but that it always requires a good bit of communication between the participating actors. So we have one, for example, project where we deal with the people from the DKFZ here right next door, which is more of a clinical researcher type institution. And they are very aware of the issue, or that there is a need for curating and generating and maintaining your data in a consistent, robust way. And I think it may be also a question of education. So we definitely are aware of this and we want to also educate on
like
the
go
problems
forward
that we
because
have there.
this is a
And
crucial issue.
we make this a topic of a hackathon with the single cell verse people in April,
That's a really big
where we
one.
talk
So
about interoperability,
things
for
have
example,
to
between
be
different
moment.
language environments. And we also have drafts for generating UI elements with some of the partners that make it easier for people that are used to working with Excel spreadsheets, for example, to get into this ecosystem. And I think this is a very unusual for us, an unusual part of the work, but something that I think needs to be done. And then it's with the community problem that you mentioned, I think it's a problem of just keep nagging, keep promoting and trying to reach a critical mass so that people are aware of the thing. And as far as now, I've made positive experiences as of how many people are aware of the project. It's just that many people don't seem to be active, but rather lurking and waiting to see what happens. So I think we need to also show some endurance when it comes to keeping this up. But I think with our track record, or particularly Julio's track record of maintaining his resources, we have a good chance. But then again, there's this element of chance
Yeah, no, I completely
in
agree.
any
And
way.
it's one
So like
great
the adoption
point, because from
rate, I
bioinformatics
can't predict that.
perspective,
We can just
when
try our
bioinformatics
best
comes capital letter,
to reach as many
and
different
when
types of
bioinformatics
researchers as
small
we can.
letter, we as a bioinformatician don't find the
Okay, thanks.
On that note, it could also be a matter of perhaps picking a couple of projects, little projects, low-hanging fruit that you could take this on and apply it and see, as a way to show, hey, this is really useful and you can get a lot out of it if you just put in a little bit of
for
effort.
this project. This needs to
That's
be
basically the whole, you
defined.
described our paper. So I think we're resubmitting next week or the week after. And we are going, because also the reviewers had this exact opinion that we need to basically differentiate between we are working really hard on our knowledge graph, and this framework really makes it easier to do that. Like showing or proving that the framework makes it easier is very difficult.
Yeah, I can see that. And on the topic of, I think you were asking about sort of opinions going forward and whatnot. So right now, I guess you've been focusing primarily on the Python side of things, and I wanted to perhaps bring in Ludwig into the conversation and put in a discussion item. Would it be worthwhile to consider hooks in R for all kinds of omics research, if that's a barrier for that community? I'm not exactly sure. Maybe Ludwig, what do you think?
No, totally. And I think Julio's group is also working extensively in R and develops a bioconductor packages. I think there's also a great interface to Omnipath in R. So I wouldn't be surprised if Julio or Sebastian already have something there to interact from the R side, or whether you guys plan anything there. Other than that, it will likely go via the usual R Python interface, reticulate, something like that.
No, we don't have something at the moment because this is all brand new. And you're right that this is absolutely not only R, but also I think one of the reviewers mentioned Galaxy, which I don't have any contact with, but I think this goes a bit into the UI direction even, but I don't know many people that use Galaxy, so I'm probably not very qualified to estimate how easy it is there. But for R and bioconductor, yes, we want to make this a topic, for example, in the interoperability hackathon in April, which is specifically concerned with the interoperability between R, Python, and Julia in this space for single cell, but also for annotations. And yeah, this will probably happen in the next months. And if anybody of you wanted to collaborate or contribute to that, we would be more than happy to get together.
No, I think that sounds great. And with regard to Galaxy, I mean, there's a huge user base out there for Galaxy that we, for those who are working, in the command line interface, are maybe not well aware of. But if you're interested in that, I mean, Julio can certainly also speak to Vince Carey, who is basically leading the bioconductor project currently, and they have a lot of ties to Galaxy through the Anvil framework, and they know a couple of folks that you could start with. Typically, these Galaxy folks are super responsive and interested in, like, you know, like building interfaces. And if you kind of like can sell it nicely to them, they might even end up implementing it, so you don't have to implement it yourself. That happened to us for a number of tools that we actually developed as bioconductor packages, and then we ended up reaching out to these Galaxy folks, and they added then modules for these packages. So if that is an interest, that's certainly something that could be done.
You know,
Well, Galaxy is not the center of my interest, but in our interest is that we reach as many people as possible so that we can do away with the redundant work that everybody's doing in building their own knowledge graphs. So yes, Vince Carey, you said, what's the name?
Yeah, Vince Carey. If you mentioned his name to Julio, he knows immediately whom to contact. I guess they speak on a somewhat regular basis.
That's great, thank you.
Sure.
Are there other questions from the audience? I have a slight clarifying question, Sebastian, if you don't mind. So OmniPath right now is already a harmonized database that brings together different data sources. Is that right? And basically you can just deploy it and it's ready to use. And so the idea would then be, if you want to extend this infrastructure, include your own data set or add your own ontologies, then you get into the sort of nooks and crannies of the work here. Is that right?
Yeah, that's completely right. So BioCypher initially was just an attempt of us to migrate OmniPath to another backend. And it kind of developed from there, in that we saw that this abstraction of the process could actually be useful for others as well. And we still have the plan to migrate. So we're doing it at the moment, migrating OmniPath to this backend. And in due course of this migration, we will also do primary adapters for all of the sources that OmniPath already has, like use the scripts to build an adapter, and then, you know, you can recombine them, because we realize that now in the lab, one OmniPath is not enough. Basically, the people working on single cell would need another version of OmniPath. And so we end up with just annotation layer upon annotation layer stacking up, and basically 10% of people use one particular configuration. So it doesn't make sense to maintain it as one thing anymore.
Interesting. I was wondering whether you were looking towards inviting community contributions to, you know, evolving the knowledge graph, but it seems like the effort might be more on the configuration side of things, because each person or each group might have their own sort of intentions, and they might not want to work with the whole gigantic knowledge graph, but rather more targeted ones. So that's
yes, and these are also in the concept. So basically, I see the use cases for knowledge graphs at the moment. I see them as a dichotomy of sorts. You have the knowledge graphs that are maintained for areas or specific workflows, something like OmniPath or the clinical knowledge graph, or Indra for that matter. Like one group is engaged in maintaining and occasionally extending this resource. And the other big part is people using them for one project, one analysis, and then they don't need it anymore, right? And at the point where we are now, these often are the same things, because people just don't have the means of going from the maintenance storage side of knowledge graph to the project-specific application-focused knowledge graph. So they end up using a much larger construct that they would actually need for their method. And what we want to do is just basically, the BioCypher could be aware of these maintained knowledge graphs, or even have secondary adapters, I call them, for these already pre-harmonized sources, like we have for the clinical knowledge graph and the Open Targets platform, for example. And then you can just select some parts, the ones that are important for your analysis, and just disregard the rest. And then you have a small, very focused knowledge graph that is also easier to share, because it's like 100 megabytes. You can zip it, put it on Zenodo, and then you have reproducibility for your manuscript. So that's It's kind of the high level view that I have of the process.
Awesome. That's great. Thank you. Clarifies things. Are there other questions from folks? Well, this has been really great, Sebastian. Really appreciate you giving this talk and coming over to the CCB seminar. So unless there are any last,
thank you for the invitation. It was great to
certainly
tell you about it.
This
And
is
if there are any questions whatsoever, feel free to just reach out in any of the channels that we give.
Thank you so very much. This is excellent work. Thank you, Sebastian, and thank you everyone for coming once again. So this concludes our CCB seminar for this week. I will see you all next time.